Hello everybody! Today I'm bringing you a new Unreal Engine 5 tutorial. This time the subject is falling sand shaders. So basically I have built two shaders, and this one is courtesy of a technique that Prismatica Dev came up with. And the other ones, the ones falling down the slopes, are a technique that I created myself. I'm gonna be going through both of these shaders in this video, how to make them, and also all the project configurations that you have to set up to be able to make something like this. Before we start, leave a comment if you have something to say about the video, and like and subscribe for new content that I'll be making every month. And finally, before we start, you can get these shaders and everything else I have made in this channel if you buy me a coffee for $5. And I would be very grateful if you could do it every month, so becoming a member of Buy My Coffee. But a one-time fee is also all you need to grab my sample project. I have been also making a physical based cell shader that I saw some other guys on YouTube coming up with. It's also gonna be there in that sample project. So it's a lot of value for $5. Let's get started making the falling sand shaders that you guys can see here. First thing, we're gonna need some meshes, and these meshes are gonna be available in the description below. These are the meshes here, so it's basically a few little wavy. I'm gonna show you guys, like if I remove the material here. Okay, so this is it. So it resembles a little bit a waterfall, right? And it's vertex painted, so the top of the little waterfall has a value of 0 and the bottom has a value of 1, and there is a gradient between the top and the bottom. So basically with this we can multiply this vertex color paint that we are not seeing here, but it's painted here. We can multiply that value by a bigger number, and then we can stretch down this little waterfall to the ground. That's why this asset is necessary to actually make this effect. We also need a cloud texture, and this one is optimized, so it has clouds in every channel. So if we look to the red channel, the green channel, and the blue channel, each one has a different set of clouds. This is also a courtesy of the Prismatica Dev. This is what we need. I'm gonna go ahead and start making a material here in my falling sand folder. It's gonna call vertical falling sand. And the first thing about it is that this material has to be a surface material, so we're gonna use it in a mesh. Has to be masked because it's gonna be translucent, but in a masked way, which means it has a kind of absolute opacity, so it's either visible or not. It's like almost binary, but you can use like a gradient value to go from visible or not visible. It's gonna use the two-sided foliage shading model, so you get some subsurface color here, and also the backside of the sand, and that's it. Let's save this. Let's pick one of those meshes that you can find in the description below. For example, let's use this one that I already messed up with, and we're gonna use vertical falling sand, which is the guy that's open over here. Okay, here we have it. It's already here. Let's be sure. So this is our guy. We want this guy to stretch down to the ground, have some wavy texture going down to simulate the sand. We want some sparkles that we can see the sun shining over our sand. That's about it. So the first thing we have to solve, this first problem we have to solve, is the size of our falling sand. What we're gonna do, we're gonna get the vertex color, which I said earlier that has a gradient painted on it, and we're gonna multiply that by minus 8,000, for example. And we're gonna place that on word position offset. Forgot to mask it. So basically we want the thing to go down. So we place it on the Z. There we go. Okay, so we can see it's falling down over our terrain. But there is a problem here. So it goes below the terrain, and that's not very good. Especially because once it reaches this part here that goes inside the terrain, the sand's gonna vanish out of nowhere, and it's gonna be very weird to look at. What we want to do, we want to actually have this waterfall fall up to the ground, not fall this much that we are seeing here. What we want is to sample the word height, and to do that we need a virtual texture. So I'm gonna create one here just to show you a virtual texture. The runtime virtual texture here. Let's name it word height texture, and when we click on it, we're gonna select word height in this virtual texture content. So this texture here will have the word height content where we put it, and then we're gonna raise the size of our virtual texture to the maximum size so we have more resolution on our word height. And this is very important because otherwise we get faulty data to work with and nothing works in the end. This is very important, and everything else I think can stay as it is. Then you're gonna go to your word you're seeing, and you're gonna create a runtime virtual texture volume. It's basically a box right here. The box that whatever it is, it's gonna be sampling that data. So we want it to align itself with your landscape. And there is an optimization that you can do that is actually to make it be just big enough so it covers the area until where your camera sees. So let's suppose that's let's click 12,000, and we'll do it in every direction. But basically we get this box, see? And basically this box is where we're going to be sampling the terrain data. So if we make it follow our player character, we can have a better reading of the word height, and it's only gonna apply inside of the box. So things that are out of the box are gonna be weird or buggy, like they're not gonna be behaving as we expect because there is no reading for the word height for that thing. But the places inside the box are gonna have a way better resolution at the word height, which is gonna make everything look better. So that's my hint. You can make it follow your player palm, and you're gonna have a better experience. But here I'm just gonna make it the same size of the landscape. I'm gonna use this word height texture. I'm gonna click on set bounds, and it's the size of my landscape. All right. But in my case, I'm gonna be using this one, because it's the same thing. I was just showing you guys how to do it. Now, you go here to your material, and you're gonna use, actually, first you have to go to your landscape material, and inside your landscape material, you have to sample the absolute word position and throw it at the word height in a runtime virtual texture output. So basically, whenever you have a volume, if you have a material outputting that word height to the virtual texture inside of that volume, you're gonna have that value available for you to use in the runtime virtual texture. And then you use this node here, runtime virtual texture sample. You configure it to use your word height virtual texture that we set up. Before I forget, in your landscape, you also have to add your virtual texture here in this drawing virtual textures. So you need those three assets configured together. Landscape must have the runtime virtual texture added to it. The runtime volume in your scene have to be there, and you also have to have the runtime virtual texture asset. So with those three in order, we can use the runtime virtual texture sample to grab the word height, and then we can subtract that one by our object pivot point. And then there is an issue with it. We're gonna get there soon enough. The word height minus our pivot point height, which is in the B channel here, is gonna give us the relative distance from our mesh to our pivot point to the ground. And we can place it here, so we multiply the vertex color by it instead of just a random number, and bang. Our thingy here, our waterfall, goes exactly to the size of the ground. Yay! So one part of our shader is already done. Okay, so this is the displacement. But back here to the object pivot point. This node works very well if you are working with individual meshes, but if you use the foliage painter, it's gonna break. So instead of giving you the pivot point of your instances, your object, it's actually gonna give you the pivot point of the foliage group, and it's gonna rack everything up. So searching through Epic forums, I came up with this function over here, which is super simple, which gives me the real pivot point. So basically it's you get 0, 0, 0, and then you do a transform position using the instance and particle space in absolute word space, and that's the output. You can come here and get a constant 3, 0, 0, 0, then a transform position, then you're gonna get instance and particle space, and then you can right click these guys and collapse it to a function, and you can call it like the real object pivot point. That's what I called it. So instead of the somewhat broken object pivot point, I can get like this real one and avoid having issues in the future. This is it for our drop down. Let's call it falling sand drop down. Beautiful. So now that our thing is falling into the ground, we are almost done, right? The next part is to get the sand running. For that, we're gonna need our cloud texture, and we actually need it 3 times. So I'm gonna pick it here. I'm gonna select the texture, packet clouds, and I'm gonna make 3 copies of it. And basically, how we make the falling sand effect is that we use one cloud to be our main dropping sand, and then we use another one to be our variation, which subtracts from the main sand, so it makes holes on it. And then we have a last one, which is a huge cloud that has big spaces that are black and big spaces that are white, and we make it go through both of the other clouds, so that the smaller clouds only appear when the big one is passing through, and that gives us our selling sand effect. To move our clouds, we're gonna need panners, which is basically a component that moves the coordinates of your UVs, your texture coordinates, so you get different pieces of your texture through time or through speed. So we connect then to the UVs of the texture sample, and this one, since it's a bigger cloud, we make the UVs smaller, giving us bigger clouds. Right. This is gonna move our UVs by the time multiplied by the speed. We need to get a time now node. It's gonna give us the current time. Then we can multiply it by a constant parameter that we're gonna call the falling sand speed. And faster this is, the bigger this is, the faster the pannings are gonna pan. So you connect it to the time here for our 3 clouds. And then for speed, place -1, so it goes from the top to the bottom. And you can put like 001 here so that it moves horizontally, so it changes the part of the texture that we are using very slowly to create variation. I'm gonna do it on this one here as well. And here actually I think 0.5. It's different from the one, the middle one. And here it's gonna be -1 as well. Alrighty. Okay. So if we pick the red channel here, remember these clouds are different clouds in each channel. So if you use the red channel here, you're gonna get some gray clouds moving down. Now, this is the first part of it. So this guy here, we're gonna subtract by his brother down here. His brother is gonna use the green channel. I'm gonna multiply it by a parameter here, which is gonna be the strength of the variation. Parameter, variation, strength. Place 1 here, or starter. I'm gonna subtract one from the other. This is our first composition. So here basically if we change this value here, we make it more penetrated by the other clouds or not. Basically a lot and a little. And leave it at 0.5. And finally, we're gonna get the big clouds here. I'm gonna subtract it. I'm gonna show you how it looks first. This is the big cloud, right? If we subtract it by a value, let's make this a parameter first so we can visualize it directly in the editor. I'm gonna call this one falling frequency. Place a 1 here so it vanishes. It's gone. But if we start moving it like this, at a point here at 0.3 for example, we get this. Only the brightest parts of the clouds go through. The bigger this number, the less visible the whole thing is, up to a point that you can barely see anything. And smaller the number, the more it appears. And then if we multiply that by the main clouds, we get to have the falling clouds effect only where the big clouds going through, or at least mostly where the big clouds going through. So to avoid having issues where we get negative numbers working, we're gonna saturate our values so it goes from 0 to 1, and then we're gonna use that. Basically what we did here is that when we subtract here to control our frequency, we don't want to get negative numbers from smaller than 0, because when we multiply those negative numbers with the positive numbers coming from the other clouds, then this trick doesn't work. But if we saturate it and we keep the values between 0 and 1, then when it's 0 or less than 0, it's 0, and this disappears with the falling clouds. Alright, this is the simple version of it. Now we can multiply that by a color, constant 3 vector. And here I'm gonna go and I'm gonna take a screenshot of my scenario. I'm gonna put it in Paint, and I'm gonna pick the color of my terrain sand, and you can do the same in your computer. And that color is the color I'm gonna use here. I'm gonna multiply that color with our clouds and shabang. Now our clouds are the same color as our landscape sand. Then we can pick this color, this cloud, then we can multiply it by what I'm gonna call the opacity control. It's a constant. Keep it 1 first, and then I'm gonna place it on opacity mask. And it's gone. It's because our opacity is not that controlled. Okay, so if we put at 5 more or less, it's gonna start showing. Right, maybe a bigger number would help us. Okay, all right, that's good enough. So we already have some falling sand. Yay! Now I'm gonna place the falling sand color by itself at the subsurface colors, so it look a bit better. And the last bit here for opacity is that we can use a node called Deter Temporal AA. We don't want it to be random, so we place a 0 here, and then we throw it at opacity mask, and it's gonna make things look better. Yay! So the sand looks more sandy, and I wonder why is that. What the node D13 AA does is this. So just like these hetero gradients, it pokes holes between our opacity colors, making this fake opacity gradient, which is why it looks granular like that, which it looks quite sandy, if I might say. So this part here is almost done. Now there is a problem, like you can still see that it falls just like a rectangle, right? And that's because it is a rectangle. So let's break this opacity mask here, and we're gonna do some finishing. Let's move it up, and let's make a linear gradient. Oh no, let's make a linear gradient. A linear gradient of a UV, you can have either the U, which is the horizontal coordinate, or the V, and we want the V. And since from 0 to 1 is top to bottom, we want 1 minus, which is bottom to top. And if we place it here in the base color, that's what we see. A gradient of black in the bottom going to white at the top. Then we can multiply this number to have more control of the opacity of the gradient strength. So let's create a parameter here called linear gradient strength. Say 1 here, and we place it over there. Now if I come here, I can make it darker or whiter, and here we want it to be whiter. So basically, if we put that in the opacity mask, the sand's gonna start disappearing gradually by the end of our mesh. So we want the dark bits to be around the ground. So we multiply by this random number here that I just picked out of nowhere and hope for the best. So what we want to do with this is multiply it with a friend in the future, and also multiply it with our opacity control. Our opacity control, and multiply it here with our gradients. This guy goes to the editor. Now our sand is gonna die slowly towards the end of our thingy. See, it dies before reaching the end, and gradually it does, but that's not the end of it. So let's break the opacity mask again. I'm gonna use a super special node called a diamond gradient. It has this parameter here, the fall off, which is basically the strength of the diamond. So I'm gonna convert it to a parameter called diamond gradient size. Let's call it like that. I'm starting with a 1 here. I'm gonna place it at the output so we can see how it's doing. Basically, this is what we got. That's my cell shader. Because of my cell shader, let's turn it off. All right. Okay, so this is the diamond gradient, and it doesn't really look like a diamond right now. But if we change our diamond gradient size, we get the diamond. See? So let's keep it at 1 for now because it looks very nice. And if we multiply that gradient with our linear gradient, we have a better. So now it dies in the borders and also by the end of it. This is our finished opacity control. We can place our colors back, and you could stop here at making this one, but there are 2 things that we still need to do to ensure this is a actually production ready material. So let's raise our opacity control a little bit more again, now that we have these gradients affecting. Okay, a bit brighter and color here. Okay, so now one thing we can do to make our sand look better is to pick the output of the clouds here and clamp the value. So we remove the darker bits. So anything darker than 0.3 gonna out. Then I'm gonna place it here with our sand shader base color output. This is nice and all, but if we have 2 sand waterfalls, then they're gonna fall at the exact same time, and that's bad. So we need to create randomness. So we need a random generator within our UVs. So if we use the foliage editor, we can use the foliage per instant random. So this is going to be a part of our random generation, and I'm gonna multiply it by 10 to make the values range farther from each other. And I'm gonna pick our object pivot point, and again I'm gonna use this real pivot point, and I'm gonna get the X and Y position, which is the R and G here. Gonna multiply it by a very huge number so that small variations cause huge end results. I'm gonna put 3, 4, 5, 6. So that's a big number. Then I'm gonna use the sine function to make it periodic. It's a sine from sine and cosine. So any number that crosses a value is gonna be set back to 0 and 1. I'm gonna add these guys together. This is our randomness generator. Create a comment here. Randomness generator. Now we need to pick our texture coordinates. Then we're gonna add the texture coordinates with our randomness generation and add it to each one of our panners. Okay, so now what this does is that if I pick this object here and I make a copy of it, it's gonna fall in a different interval than the other one over there. Okay, guys are doing different frequencies. So this is our speed by the time. Our cloud composition here. Our random generation's done. Our cloud composition's done. We got the color here. Our vertex displacement's done. All that is left to do is to create the sand sparkles. So let's get started with that. So to create our sparkles, we're gonna need the sparkles texture. And again, you can download these at the video description. Sparkle. And you're gonna do more or less the same thing, but here what we're gonna do is that if these two texture samples intersect, then their white spots here are gonna be on top of each other, which means that that place is gonna have a white dot. When they don't intersect, there's gonna be a black space. So if we pick this intersection and we place into our color, we're gonna get sparkles. To make these sparkles random, we have to move these textures by the time. So it's basically the same thing in the panner. And then we're gonna use also a rotator. We're gonna move our sparkles with these guys. But before we do that, we're gonna multiply 0.5 to make these textures bigger. We make the dots bigger. Now, for the time, we can get the time here. And for the coordinates, we can get the random coordinates from our random generator. I'm gonna make the sparkles a bit bigger. Right, with this, we can multiply one by the other. And if we place it in the base color and delete the opacity mask, you can see the sparkles here. We have a little issue. So basically, these sparkles are not totally black and white. They are, we forgot to move this guy here, so let's move it by -0.2. And well, since these textures are not exactly pixel perfect, they're not like white black, they have like this gradient around the points. I'm going to have to remove every point that's below a threshold. So I'm gonna put 0.3. I think that's a good number. And if it's bigger than 0.3, then the output is our number, otherwise it's 0. I'm doing this because I want to multiply this by a big number. So our sparkles are more sparkly. 0.3 might have been too much. Try 0.2. Alright, because it's better. So it's uncommon enough, and it's very intense when it happens. So we can get this number here, and we add it to base color. Then we can place that on subsurface. We can get the sparkle and put in specular. Then the cloud with the base color. This gives us back the original waterfall, but with sparkles, barely visible sparkles. Then we get back the opacity mask, and we're done. Actually, could add the sparkles to our base color. Right, got sparkles back. Place this guy back right here. We're done. Beautiful. Now if you want to screenshot the things, this is the sparkle generator. You can get the sparkle textures in the video description below. So now I can screenshot like 1, 2, 3 screenshot. This is our randomness generator. You can screenshot it as well. So 1, 2, 3 screenshot. This is our time control. 1, 2, 3 screenshot. We have our panners, so you can pick your screenshot here. One has speed of -0.5 and 0.1. The other one is 0, 0 for x, and -1 for y, and the big one is also the same. Multiply it by 0.03 to get big sample clouds. And we have our cloud composition here, so if I want to take screenshot, do it right now. 1, 2, 3, screenshot. Then we mix it with our color, our landscape sand color. Clamp the clouds to remove the darkest bits, so it doesn't make our sand too dark, or gradient sand too dark. We add it with our sparkles here, so all colors get some sparkles. Our opacity control is basically our clouds multiplied by a number, and also multiplied by a few gradients. I'll take a screenshot of our gradients. That's it. 1, 2, 3 screenshot. At the end of our opacity cycle, we use the temporal AA, which is basically a hetero gradient poking holes into our opacity mask. This is it for the falling sand drop down region for our vertex parts. That's it, folks. That's the falling sand shader. Now, this whole thing here is courtesy of Prismatica Dev. Now let's go ahead and create Lefurdy's terrain following sand shader. So what I do now is get this shader that we just made and duplicate it. Vertical falling sand shader, and this is gonna be the landscape falling sand shader. Beautiful. Now what we need a mesh. And for this one, we basically need a rectangle or square that is subdivided. I'm gonna use one of these ones. I'm gonna duplicate this mesh here, place landscape falling sand shader, save, place this guy over here. Basically, we see the issues right away. So this is a rectangle, like you can see it right here. I'm gonna change it a little bit. What we want to do here, we want it to follow the landscape, and we want the sands to fall into the right direction independently of where we put the falling sand thingy. This is a big example right here. Basically, let's put our duplicated material back here. Landscape falling sand shader. First thing we're gonna do is close this, guys. I go to landscape falling sand shader. I break here this part of the word position offset. If we take the opacity out of it and the dropping down thing out of it, we get this. It's flowing into a weird direction. Hold the clamp for now. So we are flowing into a weird direction right now, and also we are not following the terrain at all. So we have two things to fix here, two problems. The sand must fall to the right direction and speed, and we need to follow the terrain. In a naive way, following the terrain is super simple. Just delete this part here and we place this back here. Basically, our distance to the ground is where we end up going to, which is super simple. And this is possible because this is a horizontal. Alright. So this is the naive way, right? You put it straight into the word height, and you get this mumbled thing. Like, it might work better in some other places, maybe, but it's basically broken. Ugly. This happens because our word height is flawed. So our terrain is here, and we don't really get this data very well, so we get something more or less like this into our virtual texture. We need to get a better reading of this. So if we place our mesh here, instead of picking a point here and say I want the height here, we can actually pick 5 points and say give me the best height out of these 5 points. So we make a 5 sample of these points. We're gonna need +4 of these guy here, the sample of the word height, and you're gonna have to make 4 points based in to our vertex position. To make these points, we're gonna get a distance. As I showed here, I tried to make all the points the same distance from each other. So we're gonna get a constant here. It's gonna be our sampling distance. And I'm gonna use 33 because it's a number that I got through testing that works. we're gonna get our x and y, which are in R and G, and then we're gonna need x plus distance, then x minus distance, then we're gonna get y plus distance, y minus distance. Now we can make points out of it, right? So make float 3, and then we get x1 and y, and z doesn't really matter. I'm gonna leave it like that. Then we make another one. It's gonna be x minus 30 and y. Then we're gonna get x, y plus 30, and then x and y minus 30. These positions are gonna place into our sampling. Now we're gonna get 5 points of word height to sample from, and we want the word height here, and then we're gonna get the max of these two, max 2, the max of these two. So we get the highest point, and finally we get the max out of the central point as well, and that's the point that we use to sample from. We're gonna add a little number here to place it a little bit over the terrain, put this in bug, and that's it. Now we are following the terrain. Beautiful. So again, what we did here, we had our texture here. At every point, we pick the points below and around that point, and whichever point gets a higher word position, that's the point, that's the word height that we are using. And that gives us a very nice slope. Beautiful. But the sand is still going up. And essentially, the solution to the second problem is the same solution that we used for this first problem. So basically, we have a mountain here, and if we look from top down, it's this, and then if we look from the side, it's something like this. And we need to get the slopeness of our mountains, right? And this is in the x direction, this is in the y direction. So basically, we have to do the same thing. We get 4 points, and then we calculate the slope for these points with the derivative of our mountains. It's the same thing. We get all of these samples, but then the big difference though is that we have to use the slope equation or the line equation, which is basically m equals y minus y0 over x minus x0. Beautiful. X minus x0 is gonna be the next guy, which is gonna be 33, minus 33, which is the behind guy. We have the point plus 33 and the point minus 33, right? So basically, so if we multiply this by 2, we get 33 minus 33, which is x minus x0. Beautiful. Okay, we already have the guy that goes below the equation. Now, this guy minus this guy is going to be our y minus y0, right? So you got a point here. Our y here in this equation is basically our steepness. This is our y. And then at the other sampling, so like we have 4 samples, right? This one and this one. If we look at this sample here, we are looking at the distance and the slopeness that's below that distance. If we're looking at these other 2 points, it's the same thing. We're looking at this point and this point here. This is x, this is x, this is x. And then we're looking at the slopeness of this equation here, which is the y. So the slopeness is like the height, the slope height is always the y, and the distance is always the x. So divide one by the other, and we got our slope ratio in x direction. And if we do the same thing, we have to divide node here, word height here, and we divide by x minus x0 here, which is the same distance. We have the ratio, slope ratio in y direction. I can append this too to make a vector. I can clamp the values, so So we're gonna multiply this by the speed of our panners. Basically, this slope steepness is gonna be our direction and speed for our sand animation. So we don't want this to be too fast, so we're gonna control it to stay between -1 and 1, the speed. And then we can throw it at our panner speeds. So the panner speeds are around here. So instead of having a constant over there, we're gonna have a calculated value. I'm gonna use the same for everyone, but the variation needs to be varied, so we're gonna multiply it by 0.5. And now, okay, I had technical problems because I didn't use the pivot here. So basically we need to use the pivot position to get our slopeness. The vertex position is not any good at this. Should increase this value. Reduce this value. That's a bit more constant. Alright, so you can see that the only difference between this sampling point here and this sampling point here is that here we have to sample the pivot position to make our derivatives. Once you have this ball, the little white ball position is what dictates how our sand's gonna fall. This is basically it. You need 5-point sampling of the highest position for the ground. Add 5 to place it a little bit above ground. Then you need the 4-point samples of the pivot to calculate the slopeness around the mesh, so that the sand might fall in the right direction. And then you place that calculation of the slopeness into the speed of your panners. Everything else is the same to the other shader. Hope you learned something useful today. If you liked the tutorial, then leave a like, leave a comment, and follow the channel. And I hope to see you in the next video. Goodbye. Opacity control.